Hey guys, welcome back. A lot of you kind of requested that instead of me recording some videos and posting them onto the YouTube, why not we do a live broadcast event? And based on that feedback, I am kind of doing a live broadcast of this event. In this event or in this live session, we will go ahead and work with the OSPF as one of the IGP or the routing protocol. So in this short and sweet lab, we'll go ahead and configure a very basic OSPF topology within our core. We'll see how the DR and BDR election takes place, and then we'll try to influence the DR election process in such a way that we want to have a DR to be a certain router within our topology. So this will be the topology for a couple of our live streaming session. So on this topology, there are two sites basically. So there is a site A and there is a site B. So the site B, I have pretty much configured with all the things that we will be working throughout the series. So during the hands-on, we will be working with our site A. On the site A, we have a couple of the routers. If you take a look on the site A, there are close to 8 routers. So we will be making use of the routers highlighted in the blue, starting from R1, R2, R3, R4, R5, and R6. And there are a couple more routers that we will not be using for OSPF lab, but we will be making use of these routers for some of our later on labs that we will be working. And this is kind of the lab I think, I plan to cover during our these live sessions, working with the OSPF, basic ISIS, basic IGP, EBGP, working with the router reflector, MPLS, and MPLS traffic engineering. So the idea behind this lab, in this lab, we'll go ahead and configure a basic OSPF, and obviously we'll take a look at the DR and the BDR. So with that, let's just go ahead and get started. And before we, let me just go ahead and share my router R1 with you guys. Hopefully you can see. So let me arrange in such a way that we continue to see our side side A topology. Okay, hopefully all of you are able to see. And let me do one more thing. Maybe let me go ahead and increase the font a little bit. So it kind of makes more clear. So let me go ahead and increase the font size, hopefully. Okay, now I see that it should be visible to everyone. Give me one more minute and we should be good to go. Okay, hopefully now this is visible to all of you. So this will be our first router that we will go ahead and configure. And this is the router R1 that we will be working with. This router R1 has a couple of the neighbors. So we will be doing a neighborship with the router R2, which is sitting on our site A itself, as well as this router is also connected to our site B routers also. So if you see the R1 has a connection to the R2, as well it's connected to AS2 and some of the other things. At the same time, when we plan to work with this R1, I want to make sure that we are not doing any routing updates. So we will go ahead and suppress some of the routing updates on certain interfaces. So in this case, we will go ahead and suppress the routing update on the serial link between router R1 and the AS1. Same thing with this router and the other serial interface between the R1 and the router 8. So we will go ahead and suppress some of these interfaces as well as on the loopback. So we will go ahead and suppress the routing updates on some of these interfaces. And in this case, the OSPF area that we plan to use is 100, or the process ID or the process number for this one, while everything is sitting in by the backbone area, which is the area 0. So let's go ahead and quickly take a look and see what are the things on this particular router. So we can go ahead and simply do show IP interface brief. And if you take a look on this router, there is one interface loopback 0. We will be using this loopback 0 for our router ID. So when we'll go ahead and configure the router OSPF process, we will use this loopback IP address as the our router ID. Now there are a couple of the interfaces which are configured on this particular router. So if you take a look at the interface 01, is 10.131.31.209. Same way we have configured 02, 03. There is serial 10 as well as serial 11. So these are some of the IP interfaces or the interfaces sitting on this router that I have configured. And we will be making use of some of these interfaces or some of these network when we plan to advertise them into our OSPF. So with that, let's go ahead and get started. Before I do that, just to make sure, right now we don't have any neighbors or any config. As you can see, currently router R1 has no OSPF configuration. As I said, the only site I have pre-configured is our site B, which I'm hiding right now. So we will be configuring our site A, and right now we are on router R1. So with that, let's go to our conf mode. And the first thing we'll go ahead and say router OSPF. And if I press a question mark, when you configure OSPF, we are being asked to provide a process ID. And as I said, the process ID for OSPF, we will be using 100. So let's go ahead and say router OSPF 100. So with now we are inside the router OSPF. As you can see, our prompt has been changed. Now, the first thing we'll go ahead and configure is our router ID. And as I said, for the router ID, we will be making use of the loopback IP address. So let me go ahead and copy paste that one. Now, sometimes it's a best practice when you are working with any kind of routing protocol to log any time when we have a neighborship we are establishing with the neighbor. So it's good to log those changes. So we'll go ahead and configure the log adjacency changes. So that means we are logging all the kind of messages when we are configuring these neighborship between this router and the other router. So now let's go ahead and do that. Now, once that is done, as we mentioned earlier, on this router R1, there are many interfaces where we don't want the routing update. So we will go ahead and suppress those routing updates. So if I quickly show you by pressing the question mark here, and if we scroll down, there is something called this passive interface. So if you take a look at passive interface, clearly says, okay, hey, suppress routing update on an interface. If you want to suppress the routing updates on a one interface or multiple interface, you can go ahead and make use of the passive interface command. In this case, we are going to go ahead and suppress the routing update on our loopback because we don't want to form any neighborship over our loopback. So we'll go ahead and do that. Same thing, we'll go ahead and suppress the routing update on our serial links as well as the Ethernet link, which is connecting to our router 8 in this case. So we don't want any kind of routing updates on these interfaces. So let's go ahead and make use of the passive interface command. Now with the passive interface, we are being asked to okay, hey, provide the interface detail. So first thing, we'll say the loopback 0. Now with that, let's go ahead and repeat that. We definitely don't want any routing update in our serial interfaces. So we have the serial 10 as well as I have serial 11. Now the other interface which is connected to R8 is E01. So let's go ahead and do that. So we'll say passive interface Ethernet 0/1. So far we have started our OSPF process. We went ahead and configured our ID. We enabled the logging and we configured the passive interface. Now, the main thing is now we need to go ahead and start advertising the networks within our OSPF. So for that, we can go ahead and make use of the network command. And if I quickly scroll up, if you take a look here, the network, enable routing on an IP network. So we will be making use of the network command. So let's go ahead and type the network. With the network, we are being asked to specify a network number. So my first network that we plan to advertise is 10.131.31.1, which is our loopback. So we'll go ahead and advertise our loopback. And if I press a question mark, we have to provide the wildcard bits. So in this case, 0.0.0.0. And then we have to provide an area. As I said, all of these routers in our topology are sitting in our backbone area, which is area 0. So let me go ahead and type an area ID of 0. If I press a question mark, that there is no further option, so we get to go. So we went ahead and advertised our loopback into our OSPF process or routing. Now let's go ahead and do the same thing for our couple of the other networks which are sitting on this router. Is 10.131, 31 dot. First one is 200, and the wildcard bits are for this one is 3 is setting in the area 0. Now the other one I have is 204. The other one I have is 208. The one more on this one is 240. And last but not least is 244. So we went ahead and advertised a couple of the networks within the OSPF. And as you can see, it clearly says, okay, hey, now we are forming a neighborship. And you can see this message showing up OSPF 5 adjacency change, process 100. And we can see our neighbor is 10.131.63.2. This is the router 2 in my site B. If I quickly show you earlier, like I mentioned, on this router R1 is connected to site B. router R2, and we can see the neighborship came up between this our site 1 router R1 and site 2 router R2. And that's what you see, the 63.2 is the loopback IP address of this particular router. Now, while this is coming up, now let's come out of this router and let's verify a few things quickly. So if you take a look at this time, show OSPF neighbor. Now we should see some neighbor, as I mentioned earlier, because we do see one message showing up. So that's the reason right now we have one neighbor, 10.131.63.2. And right now the state is full as well as a DR. So that has been selected as designated router. And you can see the interface. They are forming this neighborship is 03. And you can see this is the interface 03, which is connecting to the router 2. And that's what you see the 03 here. And it shows kind of the address on this particular interface. So now we are done with the configuration on the router R1. Now let's go ahead and similarly repeat the config on router R2, R3, R4, R5, and R6 within our pod. And we will be doing a suppression on certain interfaces, definitely the loopbacks. And as we configure, I will walk you through, but in terms of the approach, it will be pretty much the same approach. So now let's go ahead and do the configure on our router R2. So let me quickly minimize R1. Let's bring up the router R2. And let me also go ahead and increase the font size so you guys can see it better. So let's go ahead and change it to 14. Maybe I'll go ahead and next time do it for all. Maybe my default config to be 14. Now we are sitting on the router R2, and if I quickly show you right now, this is not neighbor with anyone. So that kind of indicates everything is good. If I do show IP interface brief, this is my loopback IP address right now, 31.2. And this has a couple of the interfaces. So we'll go ahead and configure that. Just to save time, I went ahead and wrote the whole command that I'll be configuring. So let me go ahead and type all those commands quickly, and then I can walk you through maybe just to save some of our time. So you can see we went ahead and started a router OSPF process 100, and we are using the router ID as the loopback of this particular router. We are also configuring the log adjacency changes. We are doing a passive interface, no more routing update on loopback 0. We are advertising our loopback into the OSPF, as well as we are advertising a couple of the other networks into the OSPF. And you can see right now, it shows, okay, here we had a couple of neighborship came up. It shows, okay, here we have a neighborship came up within the pod 2 with the router 3, pod 2, router 1, pod 1, router 1, pod 2, router 2. And as you can see, because this router is connected to a couple of the routers, if you take a look, the first line, it says pod 2, router 3. So this is our router that we are sitting right now. The neighborship came up within the pod 2, router 3. It says, okay, hey, another neighborship came up in pod 2, router 1. So you can see our router R2 is connected to the pod 2, router R1. So on this link, E03, this neighborship came up. Now it says pod 1, router 1. So this router R2, the neighborship came up between our pod router R1 and the router 2. As well as it says, okay, hey, another neighborship came in the pod 2, router 2. And you can see our router R2 is connected to pod 2, router 2. And that's what you see. So once we're done, if I come out of this, and if you take a look at the same thing, show IP OSPF neighbor, that's what we kind of see is, okay, hey, these are some of the neighbors that we see on these respective interfaces. And these are their IP addresses, their current state. It says, okay, hey, 63.1 shows right now the full as well as DR. 31.1 is also the full DR. 63.2 is also full as well as DR, and some of the other information. So now we are done configuring the OSPF on the router R2. So now let's go ahead and simply repeat the same process on our router R3. So let me go ahead and bring up our router R3. And let me go ahead and change the font size again quickly here to make it 14. And let's go ahead and start configuring our router R3. Now, before we do that, same thing, I'll just show you, show IP interface brief. These are some of the interfaces. And if you take a look here, show IP OSPF neighbor, right now there is no OSPF configuration on this router. And this is the router we are working with. So we should see a couple of neighborship coming up. So now let's go ahead and quickly configure a router process 100 and some of the other details on this router. So let me go ahead and save that. And we should see couple of neighborship coming up, and as you can see, okay, now we went ahead and formed a neighborship in the pod 2 with the router 2, within the pod 1 with the router R2, because 31.2 is this router R2's IP address. And you can take a look at some of the other details. So if we do the again show IP OSPF neighbor here, we should see a couple of these informations regarding the neighborship. And that's what we had configured. We went ahead and configured router OSPF 100, router ID. We are logging the adjacency changes. We are doing a passive interface or loopback, and then we are advertising our loopback, as well as a couple of the other network which are sitting on router R3. We are done with configuration on router R3. Now simply repeat the same process for our R4, R5, and R6. So let's log into router R4. So let me quickly log into my router R4, and I will share with you guys in a moment because my session got timed out. Now let's go ahead and change the font size again on this one to be 14, so it's has a better visibility for all of you. And let's go ahead and start configuring the router R4. So just take a look at show IP interface brief. These are a couple of the routers that we have. Show IP OSPF neighbor. Right now there is no OSPF configuration. Now let's go ahead and do the OSPF configuration on our router R4. So let me go ahead and do that. And while these things are coming on R4, let's go ahead and minimize R4. Let's do the same config on R5 quickly. So let me share my R5 with you guys, and let me just change the font size on this one too. Okay, now let's go ahead and take a look at our interfaces. Show IP interface brief. And if I take a look at right now, we don't have any config. So now let's go ahead and start the OSPF routing process on this router also. We are using the loopback ID as the router ID. We are logging the changes, and we are advertising our loopback as well as a couple of the other networks. So we are done with the 5. Let's minimize router 5, and let's come back to our last but not the least, router 6. So let me just change the font on this one too. Okay, now take a look at some of the stuff on this router too. Show IP interface brief and show IP OSPF neighbor. Right now there is no config. So now let's go ahead and do the config or start the routing process on this also. Same router OSPF 100 and some of the other things. So now we went ahead and configured the whole OSPF within the whole topology. And if at this stage, if we come back and quickly, let's maybe come back to our router R3. So I am moving screen to the router R3. So now let's take a look again on our OSPF neighbors. So right now R3 says, okay, hey, I am neighbor with a couple of the routers. It says I am neighbor with. Right now we are looking on R3. R3 says, okay, hey, one of my neighbor is in the pod 2, router 2. So it says, okay, I'm neighbor with this particular router. Okay, now let's go back, and it says, okay, I am neighbor within my pod with the router 2. So we are 3, we are neighbor with the router 2. It says within my pod, within the pod A. When I say my pod, we are talking about the site A. So the R3 is neighbor with 4 as well as with 5. And if you take a look at right now here, it says 31.2, it says a full DR, while 31.4 is BDR, 31.5 is DR other. So if everything is okay at this stage, I should be able to ping from router R3 to maybe router R1. So let's try, see if we can ping that. And the IP address is 10.131.31.1. And as you can see from router R3, we are able to ping the loopback IP address, which is sitting on router R1. We can try the same thing for our pod 2 router R1, so which is 63.1. And if everything is good, that means this router R3 is able to reach our router R1, which is sitting in the pod 2, and it's figuring out that path. There are a couple of ways. It can route via R2 and then from R2 to this R1, or it can go from this R3 to this R2 and then probably take this E03 and reach. And we can take a look at that by using simply the trace route. We can do a trace route, or we can even take a look at the show Ceph. And if I take a look at, okay, hey, 10.131.63.1, show Ceph. You can take a look at any of the interfaces if you need to take a look, or we can just do simply show IP Ceph, and that's 10.131.63.1. And you can take a look. Okay, it says, okay, hey, to reach the next hop is it's reaching via this, which is, it says Ethernet 01. So it's making use of this Ethernet 01 to go out, and the next hop it says 10.131.31.225. It's one of the other interfaces on this particular router. Now, if I quickly switch back, or maybe just quickly run this command one more time, show IP Ospf neighbor, and let's go ahead and repeat the same command, the show IP Ospf neighbor on our other router. So if I do show IP Ospf neighbor, right now it says, okay, hey, in this case, 3 is my DR, and 4 is kind of indicates, okay, hey, this is my BDR. So if for any reason, if we need to change the DR, BDR elections and any other thing, we can always go ahead and influence that particular decision by configuring certain command, where we can go ahead and configure some priority for certain interfaces, and that would change some of the other things. So we can try something pretty quick. So if I go back, and so in this case, if you see on the R5, the interface is E01, and let me go to interface Ethernet 0/1. We can go ahead and say IP OSPF. With the IP OSPF, there are a couple of things, and one of the things that says a priority, where we can go ahead and change the priority for our router. So we'll say go ahead and say priority. The priority value starts from 0 to 255, 0 being the lowest, 255 being the highest. So we can go ahead and increase the priority maybe to, let's say, 150 for this particular interface. And now let's go ahead and do that. Now at this stage, if I go back and rerun this command, if you take a look in this case, right now it says, okay, hey, full DR other. And as you can see, the priority is changed to pretty much the 150, while some of the other router has a priority of like 0, 1, 1, and in this case it's 150. And if you take a look at the show IP OSPF neighbor, we can go ahead and play around with some of these things. So let's go ahead and say, okay, hey, conft interface Ethernet 0/2, we'll say IP OSPF priority maybe 140 in this case, and take a look if there is any other change. Right now it says, okay, hey, the priority is 140. You can go ahead and verify similar stuff here. So that's how we can go ahead and play around with some of the details. Let's go ahead and, in terms of the priority, we can work with the priority, and we can definitely go ahead and influence some of the decisions related with the OSPF. So that's kind of the very basic idea behind the OSPF. Configuring the OSPF is pretty easy. You just start an OSPF process. We go ahead and configure your router ID. That way you can identify, and then you just start advertising the network within your OSPF. And again, with the OSPF, there are quite a bit of command that you can go ahead and take a look at. We can just simply do show IP route, and you can see this route is learning quite a bit of route. And if you see these route, there is an O with, if I take a look at this, some of the information here. Let me just scroll up quickly. So here O says, okay, hey, the O really indicates an OSPF route, and you can see the administrative distance is 110 for this one, and how it's learning some of that information. So you can take a look at, and there is quite a bit of, again, command with the show IP OSPF that we can take a look at the OSPF database. So let's take a look at the show IP OSPF database. We can take a look at the summary, some of the link ID, advanced router, and other things. And we will be seeing some of these things as we progress further with some of the other labs. But yeah, keep this I show IP OSPF command handy. With that, you have quite a few of the things that we can take a look at. So in this case, if you say show IP interface, we can simply say brief also. So it shows, okay, hey, similar stuff, what's happening, and a few other stuff. So that kind of really indicates, or concludes this hands-on lab with the OSPF. So hopefully you guys got a good idea in terms of configuring a very basic OSPF within our network. So you can have one pod, many routers, multiple pods. Just process is pretty much same. Just make sure you are advertising the correct networks. So with that, thank you very much.